So if you don't like completing the square, how can you get around it? What's another way that we can find the vertex, find the axis of symmetry and all that other good information without doing that? And the trick is in first finding the axis of symmetry. By putting a quadratic function in this form, we can actually steal some of the letters and find that axis of symmetry. So it's going to turn out that the equation for the axis of symmetry is equal to x equals negative b over 2a. So, but it has to be in this form. We don't want it in standard form. We want it in just the general form. So that is going to be the equation to find the axis of symmetry. And once you have that x value, remember, we can use that to help find the vertex. We know it's the same x value as the x coordinate. So that's going to be the same as that. And then to find the y value, we're just going to plug that x value into the function, into that quadratic function, and that will give us our y value. And then we're good to go. So let's do that on the same problem that we had completed the square on. So we'll take this and we'll use our little axis of symmetry formula. So in this case, b is equal to negative 12. And we can see that a is equal to 3. And if we needed it, but we don't, c is equal to 1. So we got b is negative 12. So remember, negative b over 2a. So we want a negative 12 over 2 times 3. So positive 12 over 6, which equals 2. All right, and so now let's look at f of 2. Because again, we need that y value now, so we can plug that back into the function. So we got 3 times 2 squared minus 12 times 2 plus the 1. So looks like 3 times 4 is 12 minus 24 plus 1, so which equals negative 11. So put it all together, we have our vertex, which was the same thing we just found over here. So 2, negative 11. So no completing the square necessary if you really don't want to do it. But it is nice in some instances, some applications it'll be more beneficial to have that or do it that way. So, okay, so we have two methods for getting quadratic functions into a standard form, finding out those key characteristics. So what are some other applications? Well, this one's a nice one. It says to find the equation of the quadratic function satisfying the given conditions, express your answer in the form f of x equals ax squared plus bx plus c, and that's it. So we have our vertex of negative 1, negative 4, and then we also know that it passes through the point 5, 104. Ugh. Now, the trick with this one is that they're trying to deceive you and make you want to use this format to answer the question, and you don't need it. You don't need it because we also have the other form. This form is going to be more beneficial to us to answer this question. So, what do? Well, we have the vertex. So remember, that replaces h and k. So we can plug that in. So h is a negative 1, so we got to be careful with the signs. So this will be a plus 1 squared, and then we got the k, which is a minus 4. So that's step 1, plug in your vertex. Step 2 now is we have this point that satisfies the function. So this is the x value when this, and this is the y value when that happens. So we can replace x with this, and we can replace f of x with this. So we'll plug that in there, and we got a 5 plus 1 squared minus 4. And what do you notice? The only thing missing is a. So now we can just solve this equation for a, and we are home free. So we got, let's add the 4 to the other side, which makes this 108. And we know that this is 6 squared. So we can square that pretty quickly and get 36a, and then divide. So a is equal to 3. All right, so we can plug that back into here, and we also know the vertex, and then we just have to, reconfigure the formula, reconfigure the function so it looks like this. So we got f of x equals 3 times x plus 1 squared minus 4. Now, this would be a perfectly acceptable answer if that's the way they wanted it written, but they want it written like this, so we have to FOIL it out and just combine like terms and all that stuff. So let's just do that real quick. So if we FOIL that out, we should get x squared plus 2x plus 1. And now if we distribute, excuse me, I forgot my squared there. So 3x squared plus 6x plus 3 minus 4, and then we are done. So there should be our quadratic function in the right form, passing through those points. So that is that. All right. So let's see what's on the next page. Might make this video a little bit longer, but that's okay. So the last part of this, or the next part at least, is looking at minimum and maximum values. And the big thing we should know from this, if we're talking about parabola, that can only happen wherever the vertex is. So the lowest point, the minimum point, would be at the vertex when it opens up. Just the opposite when it opens down. If it opens down, the maximum point is going to be at the vertex. So that's the one thing to just keep in mind, is that those two things have to align. So when a is greater than 0, we know it opens up. So that means it's going to have a minimum wherever the axis of symmetry is, and then the minimum value is whatever the y value is at that vertex. And just the opposite for maximum. So when a is less than 0, we know we have a maximum. It'll happen at the axis of symmetry, and the maximum value is the y value at that vertex. So let's take a look at 6. Whoops, went too far. So it says the path of a diver is modeled by the function f of x equals negative 4/9 x squared plus 24/9 x plus 12, where f of x is the height in feet and x is the horizontal distance in feet from the end of the diving board. What is the maximum height of the diver? So, which case are we dealing with up above? Since we know it's maximum, that must mean that a is less than 0, and we can see it is. A is negative 4/9. So, if we want to know how high it is, which is the y value, we first got to know how far out that we need to go. So what do? We got to find that vertex. The vertex gives us all the information we need. So remember, the shortcut to find the axis, or the vertex, is to first find the axis of symmetry. So we use our formula. So in this case, B is positive 24/9. So we're just going to have to put a negative in front of that. And A, remember, was negative 4/9. So we just have to simplify this. So negative 24/9, and so this would be a negative 8/9, because all we got to do is just put that over 1. And so now if we divide these, we can divide them, but we can also just multiply both the top and bottom by 9, and that'll cancel those out. The negatives are going to cancel out as well, so we got 24/8, which is 3. So we know where the vertex lies. It lies at x equals 3, and then we just need the y value. But remember, the y value is going to give us the height that we're looking for. So all we care about now is what is f of 3. Whoops. So negative 4 ninths times 3 squared plus 24 ninths times 3 plus 12. Fun, fun. Well, 3 squared is 9, so that's going to cancel with this 9, so we got a negative 4. 3 will cancel with this 9, so we're left with a 3. 24 over 3 better be 8, and then we got the 12. 20 minus 4 looks like 16, so 16 feet should be the maximum height that diver gets off the diving board. So, all right. Like I said, this video is going to be a little bit longer because I do want to squeeze this one in as well. So let's do this real quick. An athlete's heart rate R in beats per minute after X minutes is given by R of X is equal to 2 times quantity X minus 4 squared plus 90, where X is restricted to be between 0 and 8 inclusive. So it says, describe the heart rate during this period of time. Well, how do we start? Well, the first thing is I would say, where's the vertex? Where's the vertex? So we know the vertex, because it's in the proper format, we can quickly pull the vertex out. So the vertex is at 490. 490. So what else do we know about this parabola? Does it open up? Does it open down? Well, because of the value of A, we know that it opens up. So it's a parabola that does this, and its vertex is at 490. So, if you drew a quick sketch and said, oh, my head's in the way, you got over 4 and up 90, your parabola would do this. Something like that, right? So now it says, describe the heart rate during this period of time. So remember, we're restricted between 0 and 8. So, again, my head's in the way, sorry. So there's our interval that we're looking at. So if you had to describe it, what would you say? Well, as you're going from 0 to 8, it initially starts to come down, 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 and then it reaches a minimum at 490, and then it increases again. So you could say something as general as that. So it decreases to x equals 4, then increases. So, all right, and now for B, determine the minimum heart rate during this period. Well, looking at the graph, we can see what that minimum heart rate is. So we're just going to be careful about the units. So we know it's 90, but 90 what? So it's 90 beats per minute. BPM for short. So that is that. All right. So we'll stop there, and then we'll pick up the rest of this in the next video. So see you soon.